everybody, it is me doing the streamy thing once again. Didn't stream yesterday, or I guess this was the day before. I don't know. Either way, I was feeling a little gross and out of it, so I thought I'd try and save. Shut the fuck up! I can hear myself! I can hear myself! I can hear myself! There we are. But yeah, so I am, as the kidlets say, I'm working out of town, as I mentioned a few times. But I figured, hey, screw it, why not do a stream from where I'm at? So I am currently in my hotel's bed because I don't even have a desk here. Yeah, I just figured, hey, for something to do, why not read some pages of the C manual? So I'm limited to one screen right now, so I will confess I'll have to do some bouncing back and forth to check like chat and whatnot. So hey, if you or anybody else is in chat, then cool. Hi, how's it going? And due to hotel Wi-Fi, I have no idea how this recording will come out. So yeah, we'll see. Oh, also this is on a laptop mic, so I'll do my best not to rub myself like my palm against the mic, though it's in a very unopportune spot. So if I end up doing so, I apologize, but yeah, you get the idea. What are you looking at, fat dog? What are you looking at, fat dog? Thank you. I tried. It is, it's what I got right now. What are you looking at, fat dog? He's like really tired right now, so he's kind of just like, So, hey, we will see how this goes, and we'll go from there. Isn't that right, fat? Isn't that right? Just look at me on here. Little silly nugget. Well, without wasting too much time, let's slam into it. I'll take a drink in just a second, and then that'll be how we slide into it. So hey, there we go. Have fun. Big sippy time. Okay. Oh yeah, also, unlike normal, I only have my one screen right now, so I won't be able to sort of like dual cam chat, so I'll just double check at the end of like every chapter and go from there. There's also no tib now, unfortunately, so, yeah. Anyways, let's slam into it. So I checked the last stream, and this seems to be right where we ended. So yeah, let's go for it. 4.2.7 extent. Variables and functions, unlike types, have an existence at runtime. That is, they have a storage allocated to them. The extent or lifetime of these objects is the period of time that storage is allocated. Standard C calls this the storage duration. An object that is an object is said to have static extent when it is allocated. Oh my god, I cannot read right now. An object is said to have static extent when it is allocated storage at or before the beginning of a program's execution, and the storage remains allocated until the program termination. In C, all functions have static extent, as do all variables declared at top-level declarations. In top-level declarations, variables declared in blocks may have a static extent depending on the declaration. An object is said to have a local extent when it is created on entry to a block, or function is destroyed on exit from that block or function. If a variable with local extent has an initializer, the variable is initialized at the same time it is created. Formal parameters have local extent, and variables declared at the beginning of the blocks may have a local extent depending on the declaration. A variable with local extent is called automatic in C. Finally, it is possible in C to have data objects with dynamic extent, that is, objects that are created to destroy explicitly at the programmer's whim. However, dynamic objects must be created through the use of special library routines such as malloc, and are not viewed as part of the C language. References: auto, storage class 4.3, initializers 4.6, malloc, function 16.1, static storage class 4.3, storage allocation functions 16.1. I'm just gonna do the whole check the stream thing, chat, whatever window again. Rip Tib. Yes, Tib has died. Tib is currently offline because I am not bringing a toaster to the fucking hotel room. I mean, we could, but that would just be a huge pain in the ass. So, no. Well, yeah, carrying on with it. Let's see. Doop. 4.2.8. That is the wrong size. There's placement. 4.2.8. Initial values. There's a very bad highlight, but we're rolling with it. Outcutting storage for a variable does not necessarily establish the initial contents of that storage. Most variable declarations in C may have initializers, expressions used to set the initial value of a variable at the time that the storage is allocated for it. If an initializer is not special for a local variable, its value after allocation is unpredictable. Static variables are initialized to 0 by default. It is important to remember that a static variable is initialized only once it retains its value, even when the program is executing outside that variable's scope. Example, the following code has two variables, L and S, are declared at the head of the block and both are initialized to 0. Both variables have local scope, but S has a static extent while L has a local automatic extent. Each time the block is entered, both variables are incremented by 1 and new values are printed. Static int S equals 0, semicolon. Auto int L equals 0, semicolon. L equals L plus 1, semicolon. S equals S plus 1, semicolon. Printf, left parenthesis, quote, L is equal to %d, comma, S is equal to %d, new line, unquote, comma, L, comma, S, right parenthesis, semicolon. What values will be printed? If the blocks are executed many times, the output will look like this. L is equal to 1, comma, S is equal to 1. L is equal to 1, S is equal to 2. L is equal to 1, S is equal to 3. L is equal to 1, S is equal to 4. And so on and so forth. There is one dangerous feature of C's initialization of automatic variables declared at the beginning of the blocks. The initialization is guaranteed to occur only if the block is entered normally. That is, if control flow into the beginning of the block to the use of the statement labels and the goto statement. It is possible to jump to the middle of a block. If this is done, there's no guarantee that automatic variables will be initialized. In fact, most standard and non-standard implementations do not initialize them. In the case of a switch statement, it is normal to jump into a block that is the switch statement's body or a case or default label. So automatic variables before the first such label will be not initialized. The initialization of variable sum next will probably not occur when the goto statement transfers to the label L. This causes sum to begin with an automatic, with an intermediate value. Goto L, semicolon, ellipses, left squirrely bracket, static int vector, left square bracket 10 right square bracket is equal to left squirrely bracket 1 comma 2 comma 3 comma 4 all the way up to 10 right squirrely bracket semicolon int sum equals 0 semicolon L colon begin comment add up elements of a vector end comment 4 left parenthesis I equals 0 comma I is less than 10 semicolon I meant semicolon before as well. I plus plus right parenthesis sum plus equals vector of index I semicolon printf left parenthesis quote sum is %d unquote comma sum right parenthesis semicolon right squirrely bracket. References: goto statement 8.10, initialization of variables 4.6, storage classes 4.3, switch statement 8.7. Let's check out the chat real quickly to see if anybody said anything. See if anyone said hello. Nope, no hello. That's fine. I'll just keep cruising then. So, let's see. I just want to reference to this. Initialization of sum will not happen during the goto. Yeah, that makes sense. Let's see. 4.2.9 external names. Just highlight that a bit better. Good enough. Huzzah. A special case of scope and visibility is the external identifier, also called an identifier with external linkage. All instances of an external identifier among all the files making up a C program will be forced to refer to the same object or function, and must be declared with compatible types. In each file or each else, the result file is undefined. Let me reread that. All instances of an external identifier among all the files making up a C program will be forced to refer to the same object or function and must be declared with a compatible types in each file, or else the result is undefined. External names must be declared extern explicitly or implicitly, but not all names declared extern or external. External names usually declared at the top level of a C program and therefore have file scope. However, non-standard implementations differ on how external names declared within a block are handled. Example: the following program fragment is acceptable to many C compilers. It declares an external name within a block that uses it on the outside block. Left squirrely bracket extern int e semicolon ellipses right squirrely bracket e equals 1 semicolon. According to normal block scoping rules, the declaration should not be visible outside the block, but many implementations of C simply give E file scope blocks, so it compiles this fragment without an error. Standard C requires the declaration to have a block scope, but does not state that the prior fragment should be invalid. Technically, the behavior of an implementation in this case would be undefined, thus permitting a conforming implementation to accept the program. We think programmers should treat this fragment as a programming error even if the compiler accepts it and the runtime behavior is correct. It is indisputably an error if two external declarations, left parenthesis, in the same file or different files within the same program, right parenthesis, specify incompatible types for the same identifier. Example: in the following program, the two declarations of X do not conflict with the source file, although their behavior at runtime is undefined. Int f left right parenthesis left squirrely bracket extern int x semicolon return x semicolon right parenthesis double g left right parenthesis left squirrely bracket extern double x semicolon return x semicolon right squirrely bracket. References: external name conventions 2.5, external name definitions and reference 4.8, scope 4.2.1, type compatibility 5.11, visibility 4.2.2. Huzzah, another chapter down. Just gonna check the chat again real quickly. Nope. Okay, that's fine. Let us keep rolling and keep grooving then. Whoop, accidentally opened my drawing tablet center. That's gonna be awkward for it because I got nothing open right now. I got no drawing tablet to connect. Let's keep going on. So 4.2.10, compile time names. So far, the discussion has focused mainly on variables and functions, which have existence at runtime. However, the scope and visibility rules apply equally to identifiers associated with objects that do not necessarily run at runtime. Type def names, type tags, and enumeration constants, when any of these identifiers are declared, their scope is at the same of that as a variable defined at runtime, defined at the same location. Macros and labels are also compile time names, but the scopes are different. References: enumeration constants 5.5, scope 4.2.1, structure type 5.6, type def name 5.10, visibility 4.2.2. That was a short chapter. I'm just going to slam through it and keep going. 4.3, storage class and function specifiers. Let me highlight that good. That is a perfect highlight. A perfect or highlight has never existed. That actually very much bothers me. Just, yeah. Yeah, there we are. Perfect. 4.3, storage class and function specifiers. We now proceed to examine pieces of declarations: storage class specifiers, type specifiers, and qualifiers, function specifiers, declarators, and initializers. A storage class specifier determines the extent of a declared object, left parenthesis, except for type def, which is special, right parenthesis. At most, one storage class specifier may appear in a declaration. It is customary for storage class specifiers, left parenthesis, if any, right parenthesis, to precede a type specifier and qualifiers in declarations. Storage class, storage dash class dash specifier, colon, one of, auto, extern, register, static, type def. This means of the storage classes that are given in table 4-3, note that not all storage classes are permitted in every declaration context. Table 4-3, table header specifier, auto, table header usage, permitted only in the declaration of variables within blocks, within superscript A blocks. It indicates that the variable has local, left parenthesis, automatic, right parenthesis, extent, left parenthesis, because this is the default, auto is rarely seen in C programs, right parenthesis. Table header specifier, extern, table header usage, may appear in declarations of external functions and variables, either at the top level or within superscript A blocks. It indicates that the object declared has a static extent and its name is known to the linker. See sections 4.8. Register, table header specifier, register, table header usage, may be used for local variables or parameter declarations. It is equivalent to auto, except that it provides a hint to the compiler that the object will be heavily used and should be allocated in a way that minimizes access time. Table header specifier, static, table header usage, may appear on declarations of a functions or variables. On functions definitions, it is used only to specify that the function name is not to be exported to the linker. On function declarations, it indicates that the declared function will be defined with storage at class static. Later on the file, on data declarations, it always signifies a defining declaration that is not expected to the linker. Variables declared with this storage class have a static extent, left parenthesis, as opposed to a local extent signified by auto, right parenthesis. Table header specifier, type def, table header usage, indicates that the declaration is defining a new name for data type rather than the variable or function. The name of the data type appears where a variable name would appear in a variable declaration. And the data type itself is the type that would have been assigned to a variable name. Left parenthesis, see section 5.10, right parenthesis. Superscript A. C99 permits declarations anywhere within a block. Previous versions of C permitted them only before the first statement. Standard C allows register to be used at the type, with any type of variable or parameter, but is not permitted to compute the address of such an object, either explicitly, left parenthesis, with the ampersand operator, right parenthesis, or explicitly, left parenthesis, e.g. by converting an array name to a pointer when subscripting an array, right parenthesis. Many non-standard C compilers behave differently. They may register the use of register to objects of scalar types. They may permit the use of ampersand on register objects. They may implicitly widen small objects declared with register, left parenthesis, e.g., treating the declaration register char x as if it were register int x, right parenthesis. Implementations are permitted to treat the register storage class specifier in the name as an auto specifier. However, programmers can expect the use of register on one or two of heavily used variables in a function to increase performance. Using register on many declarations is likely to be ineffective or counterproductive. To the use of register with most modern compilers, it is likely to have less effect since those compilers already allocate variables registers as necessary. References: address operator, ampersand, 7.5.6, semicolon, former parameter declarations, 9.3, semicolon, initializers, 4.6, semicolon, subscripts, 7.4.1, semicolon, top level declarations, 4.1, semicolon, type def, names, 5.10. Woo! Chewing through this thing today. Let's heckin' go. Hello and bye-bye. Hello and bye-bye. I'm guessing you gotta go Sapphire Blue, so I will not keep you, but hey, thanks for swinging by, I suppose. Yeah. Let's vibe. It's a vibe time. Whoop. Let me just adjust one small little thing. Tip. There we are. Perfect. There we are. Whoop. But yeah, there's the existence. Nice and fun. Hum. Hum. Num. A little snacky so I can get fatty. Ha ha ha. Let's see. Look at that lazy little boy trying to see. I think a little nap. Little mega EP boy. Well, let us keep rolling, I suppose. Hum num. 4.3.1 default storage class specifiers. There we are. If no storage class specifier is specified with a declaration, one will be assumed to be based on the declaration of the context shown in table 4-4. Table 4-4. Table header, location of declaration, top level, table header, kind of declaration, all, default storage class, extern. Table header, location of declaration, function parameter, kind of declaration, all, default storage class, none, left parenthesis, i.e., quote, not register, unquote, right parenthesis. Table header, location of declaration, within blocks, kind of declaration, functions, default storage class, extern, location of declaration, within blocks, kind of declaration, non-functions, default storage class, auto. Omitting the storage class specifier on a top-level declaration may not be the same as supplying extern. As discussed in section 4.8, as a matter of good programming style, we think programmers should supply the storage class extern when declaring an external function within inside a block. The auto storage class is rarely seen in C programs. It is usually defaulted. References: blocks 8.4, parameter declarations 9.3, top level declarations 4.1, 4.8. Almost a dash there. Basically did, but we're gonna roll past it. Let's see. I'm gonna check on the chat one more time. Yeah, thought so. The Sapphire Blues has come in and disappeared. Tisk. Let's see. 4.3.2. Example of storage class specifiers. I went way off kit with that. Something like that. Let's go with that. An implementation of the Hartshort algorithm is shown next. It is beyond the scope of this book to explain how it works in detail. Heap sort algorithm. I don't know where I got harp from. Harp. The algorithm rewards the array as a binary tree, such as two subtrees of element B, index K, are elements B, index of 2 times K, and B, index of 2 times K plus 1. A heap here is used in a tree such that every node contains a number that is no smaller than any of the numbers contained by that node's descendants. That's a lot of code. Pound defines swap left parenthesis x comma y right parenthesis left parenthesis temp equals x, left parenthesis x right parenthesis comma left parenthesis x right parenthesis equals left parenthesis y comma right parenthesis comma left parenthesis y right parenthesis equals temp right parenthesis. Static void adjustment left parenthesis int v right square bracket, comma, int m, comma, register int n, right parenthesis, comment begin, if v index m plus 1 through v of n is already in the heap form, this puts v of index m through v of index n in heap form. Left squirrely bracket, register int points to b, comma, j, comma, k, comma, temp, semicolon. B is equal to v minus 1, semicolon, comma, begin. B is, quote, 1 dash origin, unquote, comma, customary heap sort, i.e. v v index of j is the same as b index of j minus 1, uncommon. J equals m, semicolon, k equals m times 2, semicolon, while left parenthesis k is less than or equal to n, right parenthesis, left squirrely bracket, if k, left parenthesis k is less than n and b of index k is less than b of index k plus 1, right parenthesis, plus k, semicolon, if b of index j is less than b of index k, swap left parenthesis b of index j, comma, b of index k, right parenthesis, semicolon, j is equal to k, semicolon, k times equals 2, colon, also known as k times 2 is equal to the result. Right squirrely bracket, comma, begin, sort v of index 0, ellipses v of index n minus 1 into increasing order, end comment. Void heap sort, left parenthesis, int v, left right square bracket, int n, right parenthesis, left squirrely bracket, int points to b, comma, int pointer b, comma, j temp, comma, temp, sorry, I'm gonna redo that line, sorry. Int pointer to b, comma, j, comma, temp, semicolon, b is equal to v minus 1, semicolon. The previous line was a semicolon as well, not comma, I think. Whatever I said last. Begin comment, put the array into the form of a heap, end comment, for left parenthesis j is equal to n divided by 2, semicolon. J is equal to n divided by 2, semicolon. J is greater than 0, colon, j minus, right parenthesis, adjust left parenthesis v, comma, j, comma, n, right parenthesis, semicolon, comment begin, repeatedly extract the largest element and put it at the end of the unsorted region. End comment. For left parenthesis j is equal to n minus 1, semicolon, for j is equal to n minus 1, semicolon, j is greater than 0, semicolon, j minus, right parenthesis, left squirrely bracket, swap, left parenthesis, b of index 1, comma, b of index j plus 1, right parenthesis, semicolon, adjust, left parenthesis, v, comma, 1, comma, j, right parenthesis, semicolon, right squirrely bracket. The auxiliary function adjust does not need to be externally visible, and so it is declared in static. Of the speed of the adjust function is crucial to the performance of the sort, and therefore its local variables have been given the storage class register as a hint to the compiler. Therefore, the formal parameter n is also referred to repeatedly within adjust. Therefore, it is also specified with the storage class register. The other two formal parameters for adjust are defaulted to, quote, not register, unquote. The main function is heap sort. It must be visible to users of the sort package, and so it has the default storage class, namely extern. The local variables of function heap sort do not impact performance. They have been given the default storage class auto. Hey, another chapter down. Dum 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 dum. Coffee. Yeah, grab the last one, little snacky. Huh? Snacky has been consumed. Let's see. There we are. Just had to adjust the pillows under my butt a little bit. Let's see. A little sippy as well. That's my sippy face. Well, yes, carrying on. Yeah, let's keep slamming with it, I suppose. Let us go. 4.3.3. Function specifiers. Function specifiers are new to C99. Function dash specifier, colon, inline. The inline function specifier can appear only on function declarations. Such functions are then terminated inline, are then termed inline functions. The specifier can appear more than once with no change of meaning, sorry. The use of inline is a hint to the C implementation that calls the function should be as fast as possible. Detailed rules for inline functions are discussed in Chapter 9. References. Inline functions 9-10. Yeah, quick chapter. 4.4. Type specifiers and qualifiers. There we go. Type specifiers provide some information about the data type of the program identifiers being declared. Oops. Additional type information is supplied by the declarators. Type specifiers may also define left parenthesis as a side effect, right parenthesis, type tags, structure and union component names, and enumeration constants. The type qualifiers, const, volatile, and restrict specify additional properties that are relevant only when accessing objects of the type through one values. I think that might be a 1 or an L. It might be L values. Type dash specifier, colon, enumeration dash type dash specifier, floating dash point dash type dash specifier, integer dash type dash specifier, structure dash type dash specifier, type def dash name, union dash type dash specifier, void dash type dash specifier, type dash qualifier, colon, const, volatile, restrict, left parenthesis C99, right parenthesis. Example. Here are some examples of type specifiers. Void, union, left squirrely bracket, int a, semicolon, char, b, semicolon, right parenthesis, int enum, left parenthesis, red, comma, blue, comma, green, right squirrely bracket, unsigned long int, char, my underscore struct underscore type, float. The type specifiers are described in detail in Chapter 5, and we defer further discussion in similar type specifiers until then. However, a few general issues surrounding type specifiers are discussed in the following sections. References, declarators 4.5, enumeration type specifier 5.5, floating point time specifier 5.2, integer type specifier 5.1, L value 7.1, structure type specifier 5.6, type qualifiers 4.4.3, type def name 5.10, union type specifier 5.7, void type specifier 5.9, 4.4.1 default type specifiers. Perfect. Originally, C allowed the type specifier at a variable declaration or function definition to be omitted, in which case it defaulted to int. This is considered bad programming style in modern C, and in fact, C99 treats it as an error. Older compilers did not implement the void type, so a rationale behind omitting the type specifier on function declarations was to indicate to human readers that the function did not really return a value, left parenthesis, although the compiler had to assume that it did, right parenthesis. Example, in pre-standard C, it was common to see function definitions like this. Comment begins, sort v of index 0, ellipses v index of n minus 1, all into increasing order. Sort, left parenthesis, v comma n, right parenthesis. I think I forget it said end comment. If not, then before sort was end comment. Int v, left right square bracket, comma n, semicolon, left squirrely bracket, ellipses, right squirrely bracket. The modern standard C style is to declare those functions with the void type. Comment begins, sort v of index 0, ellipses v of index n minus 1 into increasing order, end comment, void sort, left parenthesis, int v, left right square bracket, comma, int n, right curly bracket, left squirrely bracket, or right parenthesis, left squirrely bracket, ellipses, right squirrely bracket. Example, when using a compiler that does not implement void, it is much nicer to define void yourself than to use it explicitly than to omit the type specifier entirely. Comment begin, make quote void unquote be a synonym for type quote int unquote period, end comment, type def int void semicolon. At least one compiler we know of actually reserves the identifier void but is not implemented. For that compiler, the preprocessor definition pound define void int is one of the few cases in which using a reserved word as a macro name is justified. Example, declaration syntax, left parenthesis, section 4.1, right parenthesis, requires declarations to contain a storage class specifier, a type specifier, a type qualifier, or some combination of the three. This requirement avoids a syntactic ambiguity in the language. If all specifiers and qualifiers are defaulted, the declaration extern int f left right parenthesis semicolon would become simply f left right semicolon, which is syntactically equivalent to the statement considering of a function call. We think that the best style is to always include the type identifier, the type specifier, and allow the storage class specifier to default to at least when it is auto. Example, a final note for LALR, left parenthesis 1, right parenthesis, grammar aficionados. Both the storage class specifier and type specifier can be omitted in a function definition, and this is very common in C programs. As in main, left right parenthesis, left squirrely bracket, ellipses, right squirrely bracket. There's no syntactic ambiguity in this case because the declarator in a function declaration must be followed by a comma or a semicolon, whereas the declarator in a function definition must be followed by a left brace. References, declaration 4.1, function definitions 9.1, void type specifier 5.9. Woo! Semi-big chapter. Not really that big actually. It's more than I just absolutely hammered through it. So, hey, that's pretty neat. Let me peek on something small. Yeah, that seems okay. Let's keep slamming, I suppose. Let's see. 4.4.2 missing declarators. The following discussion details with a subtle point of declarations and type specifiers. The specifiers that are structure union or enumeration definitions define new types or enumeration constants. If you simply want to define a type, it makes sense to omit all the standard declarators from the declaration and write only the type specifier. Declarations in standard C must have a declarator, define a structure or union tag, or define enumeration constants in traditional C. Non-essential declarations were often silently ignored. Example, The following declaration constants of a single type specifier. It defines a new structure type S with components A and B. Struct S left squirrely bracket int A comma B semicolon right squirrely bracket semicolon begin comment default struct S right ending comment. The type can be referenced later by using just the specifier. Struct S x comma y comma z semicolon begin comment define 3 variables end comment. However, the following declarations are non-essential and left parenthesis in standard C right parenthesis illegal. Struct left parenthesis int a comma b semicolon right squirrely bracket semicolon comment begin no tag end comment int semicolon begin comment no declarator right comment end comment static struct t left squirrely bracket int a comma b semicolon right squirrely bracket semicolon comment begin extra storage class end comment. In this first case, there are no structure tags, so it would be impossible to refer to the type later in the program. In the second case, the declaration has no effect at all. In the third case, the storage class specifier has been specified, which would usually be ignored. You might think of a letter declaration in the form of struct t space x comma space y semicolon. It will cause x and y to have the same storage class static. It will not. In the form that will cause x and y to... Okay. References. Enumeration types 5.5. Declarators 4.5. Structure types 5.6. Type specifiers 4.4. Union types 5.7. Having fun? I hope so. I guess I'll keep rolling with it. Let's see. 4.4.3 type qualifiers. The type qualifiers const and volatile were added in C89, restrict was added in C99, and identifier declared by using any combination of these qualifiers is said to have a qualified type. So there are 7 possible qualified versions of each unqualified type. Left parenthesis, the order of type qualifiers does not matter. Right parenthesis. None of the 7 is compatible with the older or the unqualified type. If the same unqualifier appears more than once in declaration, then the extra occurrences are ignored in C99, but will cause an error in C89. The type qualifiers specify additional properties of types that are relevant only when accessing objects through L values, left parenthesis, designators, right parenthesis. Those with qualified types, when used in a context that refers to a value rather than a designator, the qualifiers are eliminated from the type. That is, the expression L is equal to R, and the type of the right operand of equals always has an unqualified type, even if it was declared with type qualifiers. The left operand, however, keeps its qualifications since it is used in the L value context. In addition to their presence at the top level of declarations, type qualifiers may also appear within pointer declarations and left parenthesis in C99, right parenthesis, array declarators. Example, when using a C compiler that does not support type qualifiers, you can specify the following macro definitions so that the use of the type qualifiers will not cause the compilation to fail. Of course, the qualifiers will also have no effect. Pound if ndef __ standard C __ pound define const begin comment nothing end comment pound define volatile begin comment nothing end comment pound define restrict begin comment nothing end comment pound end if. References: pound if ndef 3.5 __ standard C __ 11.3 array declarators 4.5.3, pointer declarator 4.5.2, type compatibility 5.11. Oh, hello, Pupper. How you doing? Are my noises making you concerned? So, I am evil, scaring the puppy. Let's see. What does the chat have cooking for us? Nothing has chat cooking for us, but I just want to check anyways. Haha. Yeah, nothing. Let's go. Let's roll forward. 4.4.4. Const. An L value expression of const qualified type cannot be used to modify an object. That is, such an L value cannot be used as the left operand of an assignment expression or the operand of an increment or decrement operator. The intent is to use the const qualifier to designate objects whose value is unchanging, and to have the C compiler attempt to ensure that the program does not change that value. Example. The following declaration specifies that IC is to be an integer with the constant value of 37. Const int IC equals 37, semicolon, ellipses, IC equals 5, semicolon, begin comment, invalid, end comment, IC plus plus, semicolon, begin comment, invalid, end comment. The const qualifier also can also appear in pointer declarators to make sure it is possible to declare both, quote, constant pointers, unquote, and, quote, pointers to constant data, unquote, colon, int, asterisk, const underscore pointer, semicolon, const int, asterisk, pointer underscore to underscore const, semicolon. The syntax may be confusing. Constant pointers and constant integers, for example, have the type qualifier const in different locations. The appearance also changes when type def names are used. The constant pointer, const underscore pointer in the previous example may be also declared like this. Type def int asterisk int underscore pointer, semicolon, const int underscore pointer, const underscore pointer, semicolon. This makes const underscore pointer look like a, quote, pointer to constant int underscore pointer, unquote, but it's not. It is still a constant pointer to a left parenthesis non-constant right parenthesis int. In fact, because the order of type specifiers and qualifiers does not matter, the last declaration may be written int underscore pointer const underscore pointer, semicolon. You can alter a variable that has the type, quote, pointer to const data, unquote, but the object which it points to cannot be altered. Expressions with this type can be generated by applying the address operator, ampersand, to values of constant qualified types. To project the integrity of constant data, assigning the type value, quote, pointer to const t, unquote, to an object of type, quote, pointer to t, unquote, is allowed by using an explicit cast. Const int asterisk pc, semicolon, comment begin, pointer to constant integer, end comment, int asterisk p, comma I, semicolon, const int ic, semicolon, PC equals P equals ampersand I, semicolon, comment begin, okay, end comment, PC equals ampersand IC, semicolon, comment begin, okay, end comment, asterisk P equals 5, semicolon, comment begin, okay, end comment, asterisk PC equals 5, semicolon, begin comment, invalid, end comment. PC equals ampersand I, semicolon, begin comment, okay, end comment. PC equals P, semicolon, comment begin, okay, end comment. PC equals ampersand IC, semicolon, comment begin, invalid, end comment. P equals PC, semicolon, comment begin, invalid, end comment. P equals left parenthesis int asterisk, right parenthesis, ampersand IC, semicolon, comment begin, okay, end comment. P equals left parenthesis, int asterisk, right parenthesis, PC, semicolon, comment begin, okay, end comment. The language rules for constant are not foolproof. That is, they may be bypassed or overridden if the programmer tries hard enough. For instance, the address of a constant object may be passed to an external function without a prototype, and that function could modify the constant object. However, implementations are not permitted to allocate static objects of const qualified types in read-only storage, so that attempts to alter objects could cause runtime errors. Example, this program fragment illustrates some dangers in circumventing the const qualifier. Const int asterisk PC semicolon, int asterisk P semicolon, const int IC equals 0 semicolon, ellipses, PC equals ampersand IC semicolon, quote begin, okay, end quote, P is equal to left parenthesis int asterisk P, or sorry, int asterisk right parenthesis P, space C semicolon, comment begin, valid, comma, but dangerous, end comment, asterisk P equals 5, comment begin, valid, but may cause a runtime error, end comment. Finally, a top-level declaration has the same type qualifier, const, but no explicit storage class is considered to be external in C. References: assignment expression 7.9, increment and decrement expressions 7.4, pointer declarations 4.5.2. Honestly, this next chapter is a very long one, and I'm feeling a touch burnt out, so I think I'm going to end it here. A wee little short baby stream, but you know what? Hey, don't say I didn't try. So, with that being said, hey, thanks everybody for peeping, checking in, saying hi, and those of you who didn't. And yeah, I'll catch you later. So, oodly too. Bye-bye.